Assalamu alaikum. Today we want to talk about lecture 2 in chapter 3, stoichiometry, calculations with chemical formulas and equations. Interconverting masses and moles. Let's look at this exercise for converting grams to moles. Now calculate the number of moles of glucose in 5.380 gram of glucose. Now number of moles equal mass divided by the molar mass. So here the conversion factor is that 1 mole glucose weighs 180 gram glucose. So moles of glucose, we multiply the number of moles of glucose given times 1 mole glucose divided by 180 gram glucose. Here gram glucose with the gram glucose goes, and we have this number 0.02989 mole of glucose. Notice here the answer contains 1, 2, 3, 4 significant figures as this mass. 1, 2, 3, 4 significant figures. Also, you can here practice on this exercise how many moles of sodium bicarbonate are in 508 gram of sodium bicarbonate, also known as sodium hydrogen carbonate. And you can check your answer here. After that, we go to interconverting moles to grams. Second sample exercise, calculate the mass in grams of this number of moles of calcium nitrate, the same as we did before. This is the same as the one we solved. This moles of calcium nitrate cancels with moles of calcium nitrate. Notice that this number here, 164.1, is the molar or molecular or formula خلينا نقول weight of this ionic compound. And this is the final answer. Now, if we look at this figure, it shows us a procedure for interconverting mass and number of formula units. So, you can start with grams, use molar mass to convert to moles, and then use Avogadro's number to convert to formula units. Now, the mole concept provides a bridge between mass and number of particles. Now, in this sample exercise, we want to see calculating numbers of molecules and atoms from mass. How many molecules are in 5.23 gram of glucose? Notice here, molecules of glucose. First, we convert the mass into moles, as you can see here. Then multiply by Avogadro's number to get the number of molecules of glucose. You see here, this gram glucose goes with this gram glucose. Now, how many oxygen atoms are in this sample? So, oxygen atoms, how many in this amount of grams? Again, each molecule of glucose contains each molecule contains 6 atoms. So atoms of oxygen equal each molecule contains 6. So we multiply these number of molecules times 6 divided by 1 molecule, and then you get this answer. So again, molecule of glucose cancels with molecules of glucose. So as I said, the general procedure for interconverting mass and number of formula units is summarized in this sample exercise. So if you understand this, then you will be in good shape. Now, section 3.6, quantitative information from balanced equations. Now, the coefficients in a balanced equation indicate both the relative numbers of moles in the reaction. Now, the mole ratio is the ratio of the coefficients of two substances in a chemical equation. You must use the mole ratio to convert from one substance to another. If you look at this balanced equation, these are the conversion factors. 1 mole of ethanol reacts with 3 moles of oxygen. 1 mole of ethanol produces 2 moles of CO2. 1 mole of ethanol produces 3 moles of water. Now, 3 moles of oxygen produce 2 moles of CO2. 3 moles of oxygen produce 3 moles of water. 2 moles CO2 produce 3 moles of water. So, by using these coefficients, you can interconvert from one reactant to another, or to find the product too. Now, stoichiometric calculations. If we look at this equation, 2H2 gas plus O2 gas to form H2O liquid. Now, we can envision it in the following way. If we look at the number of molecules, we can say we have 2 molecules of H2 reacts with 1 molecule of oxygen to produce 2 molecules of water. And you can see here the representation. The mass in AMU for 2 moles is 4 AMU H2, for oxygen 32 AMU oxygen, for water twice, 36 AMU. Now, the amount in moles, 2 moles H2, 1 mole oxygen, and 2 mole. This is from the balanced equation. And then again, the mass we convert from, we said AMU is the same as gram. So here we have 4 gram plus 32 gram to produce 36 grams. So here, as you can see, the coefficients in the balanced equation give the ratio of moles of reactants and products. As I explained, this shows how this result corresponds to the law of conservation of mass. So we can say that 2 mole of hydrogen stoichiometrically equal to 1 mole of oxygen, stoichiometrically equivalent to 2 moles of water. Now the symbol means stoichiometrically equivalent to. And you can use this principle in order to solve any problem. Now, stoichiometric calculations. Now, starting with the mass of a substance A, for example, here, if you are given grams of substance A, you can use the ratio of coefficients of A and B to calculate the mass of substance B formed if it is a product, or used if it's a reactant. So, given this, use the molar mass of A, convert it to moles, use the coefficients to convert moles of A to moles of B, and then use molar mass of B to convert moles of B into grams of B. So this is, if you understand this relationship, then you can perform or solve any equation. Calculating amounts of reactants and products. Now, suppose here we have the following equation. The oxidation of glucose into CO2 plus water. This is a balanced equation, as you can see. Notice here the superscripts. S here is solid, gas, and here liquid. How many grams of water are produced in the oxidation of 1.00 gram of glucose? So, first of all, as I said before, 1 mole of glucose stoichiometrically equivalent to 6 moles of water, as we said on the last slide. So now, first step, use the molar mass of glucose to convert from grams glucose to moles of glucose. Here you see, times 1 over 180. This with this goes. Then use the balanced equation to convert moles of glucose to moles of water. So moles of water equal, and the result of this times 6 mole of water per 1 mole of glucose. This with this goes. And then in the last step, use the molar mass of water to convert from moles of water to grams of water. And then you add the third conversion factor. You multiply by 18 gram water per mole of water. This with this goes. And the final answer is this one, 0.600 gram of water. Notice here, the final answer contains 1, 2, 3 significant figures as in the given mass. 1.00 contains a 3 significant figure. Remember this. Another sample exercise, calculating amounts of reactants and products. If you are given the following reaction, lithium hydroxide reacts with carbon dioxide to form lithium carbonate and water. How many grams of carbon dioxide, molecular weight 44, can be absorbed by 1 gram of lithium hydroxide, formula weight 23.95. So you are given the balanced equation. Suppose this equation is not balanced. So the first step, you balance the equation by inspection. But this is balanced. So we are given 1 gram only. So here 2 moles of lithium hydroxide corresponds to 1 mole of CO2, or reacts with 1 mole of CO2. So we convert the grams of LiOH into moles of LiOH, then we convert to moles of CO2, then grams of CO2, and we use 3 conversion factors. Then in one step here, grams of LiOH is converted to moles. This cancels with this, and then moles converted to moles of CO2. Notice that we multiply by 1 over 2. This goes with this. And finally, we multiply by 44.01 gram. This is the molecular weight of CO2 per 1 mole of CO2. This cancels with this. And then you get your final answer, 0.919 gram CO2. Remember again, the number of significant figure here is 3, and here is 3. So this is correct. Now, limiting reactants. Limiting reactant or limiting reagent, the reactant that is completely consumed in a reaction. The other reactants are called the excess reactants or reagents. The amount of product is always based on the limiting reactant. Notice here, if you have, these are the reactants, and a combination should occur between 1, 2, 3, 4 components. So you have 3 full products, and these are called excess reactants. These are called excess reactants. Now, in chemistry, we can give this example. Suppose in a vessel here, we have, you place 10 molecules of hydrogen and 7 molecules of oxygen. 1, 2, 3, 4, 5, 6, 7 oxygen in red and 12 hydrogen, and you allow them to react according to this equation. So each 2 hydrogen atoms will combine with 1 oxygen atom to form water. So here you have the result is formation of 10 water molecules, and 2 O2 remains, but no H2 molecules remains. So before reaction, you start with 10 mole of this, 7 mole of this, and 0 mole of water. The change you expect that, لاحظوا here, all the 10 hydrogens react, and only 5 reacts from the oxygen, and 2 remains, and the product's 10 mole. Now, the substance that is consumed first is called the limiting reactant. So hydrogen here is our limiting reactant, and because oxygen is in excess, as you can see here. So this explains the meaning of limiting reactant. Now, determine the limiting reactant for the balanced equation. This is another look at the same problem here. Initial quantities, change, final quantities. Now the reaction stops when H2 is consumed, so H2 is called LR, a limiting reactant. Now excess of reactant, 7 mole of oxygen minus 5 mole of oxygen, 2 moles of oxygen excess. So this is your guide for determination of the limiting reactant. Reactions contain more than given amounts of reactants and limiting reactions. Convert grams of reactants to moles. Divide the results of each mole on its coefficient in the balanced equation. The smallest value is for the limiting substance. Your calculations should be based on the limiting reactant. Why it's called limiting reactant? Because it limits the amount of products formed. So if we look at this example, calculating the amount of product formed from a limiting reactant, given if you are given this reaction between nitrogen and hydrogen to form ammonia, how many moles of ammonia can be formed from 3 moles of N2 and 6 moles of H2? So notice here, we are asked to calculate the number of moles of product given the quantities of each reactant. Thus, this is a limiting reactant problem. Solve. The number of moles of hydrogen needed for complete consumption of 3 moles of N2 is this. Moles of O2. 3 times 3 divided by 1, 9. Now, because only we have 6 mole of H2 is available, we will run out of H2 before the N2 is gone, and H2 will be the limiting reactant. We use this quantity of limiting reactant, H2, to calculate the quantity of product. So moles of product, 6 times 2 divided by 3, and you get 4 moles of NH3. Again, you can generate this table in order to solve this problem. Another sample exercise calculating the amount of product formed from limiting reactant. How many moles of ammonia can be formed from 3 moles of N2 and 6 moles of H2? Here again, this is a simple way to calculate this question. Here you are given 3 mole with 6 mole. Now What is the coefficient for nitrogen? It's 1. 3 divided by 1, 3. Now, what is the coefficient for hydrogens? 3. 6 times 6 divided by 3, it's 2. Which one is smaller? The smaller one is the limiting reactant. Yani the one which gives us the smaller ratio is the limiting reactant, and accordingly we say okay. 6 in the equation, 3 moles produces 2 moles. Now 6 moles produces how many? 6 times 2 divided by 3, and you get 4 mole of ammonia. So this is a direct way to solve the previous problem. Again, you can practice the following exercise by yourself, and you can check the answers too. Here, calculating the amount of product formed from a limiting reactant. Suppose you have the following reaction. You start with 150 grams of hydrogen and 1500 grams of oxygen. How many grams of water are formed? So again, the first step always to convert the grams into moles. So moles of hydrogen, 150 divided by 2, 75 moles. Moles of oxygen, 1500 divided by 32, 47 moles. Now, what is the coefficient for hydrogen? 2. So 75 divided by 2, it is 37.5. What is the coefficient for oxygen? 1. 47 divided by 1, 47. Which ratio is the smallest? Smaller is this ratio. So H2 is limiting, and it limits the amount of product. So you can say 2 produces 2, 75 produces how many? So 75 times 2 divided by 2, then you convert it to grams of water, and you get this 1400 grams of water. If you want to two significant figures, you want to write this down, you can put 1.5 times 10 to the 2. 1.4 times 10 to the minus 2. Also in B, how many grams of reactant present in excess remain after the reaction is consumed? Again, here we have 150 grams. How many grams reacted? إلى آخره. So gram of oxygen reacted, 75 times 1 divided by 2, لأنه هون 2 reacts with 1, 75 reacts with how many? 75 times 1 divided by 2. Then you multiply by the molecular weight of O2, 32 grams per mole, gram-mole of oxygen per mole of oxygen, and you get this 1200 grams. So excess oxygen origin 1500, we started with 1500, minus reacted 1200, and we get 300 grams. This is the excess amount of oxygen. Percent yield. Now, an important indicator of the efficiency of a particular lab or industrial reaction. The percent yield of a reaction relates the actual yield or experimental yield done in the lab with the theoretical yield calculated using stoichiometry. And the actual yield is always less than the theoretical yield. Why? Because of incomplete reaction, side reactions, some product lost, personal error, etc. Note that percent yield should never exceed 100, or your answer is wrong. And this is the law you use to determine the percent yield. Divide the actual yield, the one you get from the experiment, over the theoretical yield, the one you calculate from the balanced equation, times 100, you will get. So this percent yield should never exceed 100. And the actual yield is always less than the theoretical yield because of these reasons. Note them. And here a sample exercise calculating theoretical yield and percent yield. From this balance equation, adipic acid reacts is combusted or oxidized to the following compound. Adipic acid is formed by the oxidation of cyclohexane as you given in this equation. Assume that you carry out this reaction starting with 25 grams of cyclohexane and 100 grams of oxygen. What is the theoretical yield of adipic acid? Again, convert to moles. Moles of this equal 25 times 1 divided by 84, of course, is the molecular weight of cyclohexane, 0.3 mole. Moles of oxygen, 100 times 1 over 32, 3.12 mole. Again, what is the coefficient of cyclohexane? 2, 0.3 divided by 2, it's 0.15. What is the coefficient for oxygen? 5. So 3.12 divided by 5, it's 0.63. So which ratio is smaller? This one. So cyclohexane is limiting reactant. So it limits the amount of product. So we can easily now find grams of adipic acid by converting grams of cyclohexane into moles of cyclohexane, and then use these from the stoichiometry, from the balance equation, converted to moles of adipic acid, then to grams of adipic acid. Notice that here 146 is the molecular weight of adipic acid, and you get this 43.5 gram of adipic acid. Now, this is called the theoretical yield. This is called the theoretical yield, the one we calculate, as you can see. But if in the lab, when you did the experiment, you obtain only 33.5 gram of adipic acid from your reaction. What is the percent yield of adipic acid? Now, percent yield equal actual divided by theoretical times 100, and 33.5 divided by 43.5 gram times 100, it is 77.0%. This is called the percent yield. Notice the answer, 3 significant figures as this mass, and also this as the mass. Now the final slide here contains a practice exercise. You can do it if you understood the problem, then you can solve it by yourself. If you start with 150 grams of Fe2O3 as the limiting reagent, what is the theoretical yield of iron in this equation? Notice that in some questions they give you the limiting reagent, so no need to find it. So this makes things easier. So here in the equation, he tells you that Fe2O3 is the limiting reagent. So no need to determine the limiting reactant, and you say مثلا 1 mole gives 2 mole of iron. Then you divide this 150 gram by the molar formula weight for this compound, and then multiply by the atomic weight of iron, then you will get this mass of iron. Now, this 105 gram of iron. Now, if the actual yield of iron in your test was 87.3, what is the percent yield? So, actual divided by theoretical times 100, and you will get this answer. This is end of lecture 2. Thank you. And end of what is required from this chapter 3.